In this video, I'll be talking about MCP, Model Context Protocol, and how MuleSoft is leveraging its capability. We'll go through evolution of AI, why MCP, MCP architecture, and then a demo using MuleSoft MCP Server. So let's get started. At this year's NVIDIA event, its CEO had spoken about evolution of AI. And speaking on the similar lines, I would like you to take ahead on the MCP. In 2012, we had AlexNet, which laid the foundation for the modern convolution neural network. And then it paved way for the perceptive AI to develop further ahead in speech recognition, recommendation system, and imaging systems. And then in 2018, Google had released the transformer model and the generative AI phase began, wherein the digital marketing, content creation got a boost. And then we got into the agentic AI phase. And currently, the customer service, the coding assistant are getting the capabilities which are really wonderful. And further ahead, it will be also supporting the physical AI, wherein the robotics, self-driving car would take making use of the previous advancements. But our focus here is from the generative AI to the agentic AI phase. So what we had is the reactive AI, which were the rule-based systems. Kind of the if-else type of chatbots were there in the space. Then we had the narrow AI, which were the task-specific intelligence. Example, spam email filtration, Google Translate, and the routings that you see in the maps. And then we got into the LLM chatbots, wherein the chat GPT gained traction, and then we had the Einstein Copilot as well. And now we are having this AI agents, Agent Force, the Auto GPT are example for it. And what is an AI agent? Basically, they are the AI which can perceive its environment, reason about it, and take actions to achieve the specific goals. And this is where the MCP comes into the picture. And later on, we will be seeing the AI agents communicating with each other, which are having the different goals and creating an agentic ecosystem basically. So for this, we have we need to stabilize the AI agents and need further developments in it. But let us now explore what is MCP and why MCP and how it helps in building this AI agent. An LLM, large language model, works well with static prompts, answer questions, summarize document, generate code, but lacks the capability to perceive, plan, or act. LLMs are stateless in nature. They do not retain any memory of past. So to solve this, a general approach started with integrating tools which would provide LLM this capability. But when we talk about tools integration, this custom tool integration creates a barrier when we see from the viewpoint of scaling it. It also becomes an overhead to develop custom solution for each new tool capability based on its language and functionality. So this is where MCP helps by providing a standardization. It acts as a layer between the LLM and tools, just like a USB-C port for AI to connect with tools which can be of any type. So let us understand with an example. If you have an LLM and you ask it that I want to send an email, so it would basically lay down the instruction to send an email, but it won't send an email. And if we see an LLM which is now integrated with this MCP and the tools, it is now an AI agent which would basically perform a task to send an email. It has a specific goal in its mind to send an email by understanding context from these tools and and its capabilities to send an email. So now if an user asks to send an email, it would basically able to send an email. So this standardization basically leads to several benefits like context-aware interaction, autonomous decision making, reduced menu orchestration, and further ahead, the multi-agent collaboration would also be benefited from this. Moving ahead to MCP architecture, it basically has three main components: the MCP host, which can be the LLM chat app or the coding assistant, then the MCP client, which basically acts as a communication interface between the host and the server, and then we have the MCP server, which is basically having connection to the database or the API or any other tool. The official documentation uh, explains the detail ahead, like how the protocol works and other examples about it. So here, as you can see, it has a three participant MCP host, client, and server. And here, as for this diagram, you can see the MCP host has the MCP client, and each client has one-to-one connection with the MCP server. And it acts on the data layer, the transport layer. And so you can explore this document ahead and understand more about the MCP, and we can now move ahead to our demo. So in this demo, I have created a flight booking AI agent, which is basically utilizing the Claude AI. And this Claude AI has the MCP host and the MCP client. And my MCP server is basically on the MuleSoft, wherein I'll be running this application locally, which is the My Flight server. And this is connected to the MongoDB database. And we have another MCP server, which is the mail server, which is hosted on Cloud Hub 2.0, and it's connected to the MailJet for the notification services or the email service. So this is how uh, the demo will look like. Let's start the demo with understanding the flight booking system in this AI agent. So here we have the user, then we have the Claude Desktop AI, which contains the Claude LLM and the Claude inbuilt MCP client. Then we have the MuleSoft, wherein we have built the MCP server, which is then connected to MongoDB and MailJet. So initially, the MCP client and the MuleSoft server will initialize its connection by reading all the available tools with context and parameters. And then internally in the Claude, the LLM will be checking all the available tool which it has, and the tools will be providing the context and parameter. So now let's say the user requests for a flight booking, and it will then, the LLM will basically check the relevant tool, and it sees that search flight tool is available within it, and it has a prompt which requires to validate user prior to booking. So basically it would just initially form the payload and send it to the MCP server, and the MCP server then will be querying, the MuleSoft will be querying the database into this flights collection and get the flight details, and then provides the user with the flight selection option in the natural language. And once the user selects the flight, then another tool gets activated as it required to validate the user. So it will ask the user an email ID for the verification. Then if the user provides a proper email ID, then similarly the payload will be formed and sent to MuleSoft in the MCP server, and then it will query the database and check if the user is correct or not. Then similarly now here it has all the relevant information for the flight booking and details. Then it will check for a relevant tool. Then it finds that it has a booking agent tool which does the booking process. Then all the payload will be set from the user interaction here, and then that payload will be sent to MCP server, and then MCP server will be sending that to MongoDB database. Basically, the orchestration will be happening here, which will be like fetching the flight details and update the flight details like available seats and all the other details which might be required to update into the common flight database. And then will updating the booking details with a PNR number, and then a success message will be returned to the user with PNR. And once that user has got that successful booking with a PNR reference, then an email will also be triggered, as there were prompt also set in the tools that please send an email once the successful booking is confirmed. So then email will be processed using that mail jet, and that mail success will be sent to the user in the LLM as well as in the email. So user can receive a successful flight booking email. So this is how the booking process would typically occur. And we have the cancellation process as well. Let's say user queries flight cancellation with the PNR number. Then the LLM will be checking the relevant tool which is available for book cancellation of the booking, and it sees that cancel booking is available, and then it would form its payload. And as per the prompt, I have set that the refund policy agreement as false to be sent. So it basically sends the PNR number and the refund policy agree as false initially, and then basically the process will start at the server that it would fetch the booking details, and then based on it would search the flight details, and the flight details will contain the refund policy which is there. And then and it has checked that refund policy agree is false, and it would basically send a prompt to LLM that please ask user to agree to the refund policy, and the refund policy details are as follows. This would be sent as a payload, and then the LLM would be uh, reading that policy to the user, and showing basically to the user, and it will be asking the user to agree it. And once that user agree to the policy, then the PNR would be set again in the payload, and the refund policy agree will be now set as true. And then the server would receive the payload, and again similar process would start. It would fetch the booking details and the flight details and update the flight details, whether if any relevant details needs to be updated, and then update the booking status into the booking collection as cancelled. Then the cancel confirmation will be sent, and the payment comments will also be attached with it, and the LLM will provide the user with the cancel communication. And as for the prompt, it also needs to send an email, so it will identify send email tool again, and then form an email and send an email to user that your cancellation process is now successful. So this is how the demo would be moving forward. So now let's go ahead and see how it's working in real time. So I have now opened up the Claude AI desktop, and I'll be checking in to book flights. Hi, I am looking to book flight from Pune to Delhi. I provided a prompt, so Now it has identified the search flight and it has find this available flights here and has provided in the option. You see this? So it has sent the request as arrival airport, departure airport, and it has received the flight details as in payload, and it has provided in the natural language to select an option. So let's say I'll book a flight. Please book a flight and go first. So it has started the process. So now what it is asking, it is asking validation. So I'll have to provide an email. I'll provide my email. So it has now identified the get user tool from it. If I expand this, you can see the request payload, and then you can see the response that it got, that the user is correct. Now it also requires one more additional thing, is how many persons will be traveling and what date would be booking. Okay, so since that in the data I have stored the previous dates, so I will just for now ignore this, but you can say it's for myself. So it has now identified the booking agent and it has sent all the relevant details here, and now it is sending. It has got messages booking successful as well. Now it is sending an email as well. Here it has sent an email as well. That is also success, and it has provided me with a PNR number here. Let me check the email as well. I've got a booking and flight booking confirmation mail as well in here. So yeah, now let's say I want to cancel this PNR also. So I will just open a new chat to have a new context. So hi, I want to cancel my flight with PNR this. So it has initiated the cancel booking, and here you can see it has sending initially as refund agreement as false, and it has returned with the refund policy payload, and here it is saying this is non-refundable cancellation fees this, and do you agree or not, right? Then I say yes, I agree. So again the cancel booking has been initiated, and here you can see refund agreement is true now. It has cancelled, and it is now sent a confirmation email as well to me to send. Check here once. So maybe due to some network issue the email might is not, but similarly you can see the flight booking confirmation as well, right? So this is how it is working now. So now once we have seen this live demo, we'll move to the MCP code which is there in the MuleSoft application. So majorly it's nothing, but we are using this MCP connector tool here. So here we have different types of connectors under the MCP section. So I have used the MCP server tool listener only, and it's basically, if you see, the connector configuration has the MCP server in it, and if I open this, it has the listener configuration listed. So the normal HTTP listener config that we usually mention, so it is defined in here. And then we have the endpoint path, the message path here defined. We have the server name defined here. And again, if I go to the connector, then there is the tool name defined here. And then in the description is the basically the prompt that you can give to the LLM can is defined, and the description the rule is the basically description or the prompt you can say it. And here we have the parameter schema defined. So this basically tells the AI that this is how API can how the MCP server can accept the payload. And this is in the responses. Once the execution completes, then what do you need to pass? So here the payload needs to be passed to the client once the execution in the server completes. Similarly, here I have defined for the search flight, the description contains the prompt and the parameter schema of how the payload that I would be accepting it, and then the response that I would be sending it. And here the get user, the description similarly for all of them. And here, so here is the flow. If so, this is how the MCP connector eases the job of creating an MCP server inside the MuleSoft. So this, let's say already you have an existing flight booking APIs. You can just add this MCP implementation layer in it and refer to it as a flow reference there. And this is basically the orchestration that is happening for the booking and the cancellation process, the API. And the MCP connector currently works in Mule runtime 4.9.6 and above and would require Java 17. And so how it's working, I have initialized this as the SSE, but in the Claude, it requires the standard input output. So what I have done is I have basically used the super gateway command to convert the SSE into the standard input output server listening mode, and similarly for the Cloud Hub URL as well. And this is for the local. And let's say if we want to test this, right? So for testing APIs we have Postman. So similarly for testing MCP server we have MCP inspector. So this is the MCP inspector. So I will just, for this you would require a Node.js uh, installed. I'm starting the MCP inspector. So this is how the AI would be reading it. So I will, the URL, this is the local URL I will be connecting it to. And I have the tools and I will list the tools. So here you can see all the tools getting listed and how it is initialized here, and the tool is getting listed. Get tools in the description is there. And based on that parameter schema, you can see that email as a text, it is accepting for the get user. Booking agent, it requires different inputs, and this is being read from the parameter schema. So this is how you could test the MCP server. And if you see here how I have configured this, so if you can go to the settings, and the settings you have the developer section. So this is where the local MCP server needs to be configured. And if you click on the edit config here, it would lead to this Claude desktop config file, wherein the server needs to be mentioned here. So this all you can find in the Anthropic's MCP connector article. I have also mentioned in the references, and I'll put that in the description as well. So this is how in the backend it was handling it. So the user is communicating with this chat interface. User is communicating with the chat interface, and then at the back end we are having this settings to communicate with the server, and this uh, config is basically communicating with this, wherein the standard input output is getting converted to SAC, and this also this for the local standard input output to SAC, and then getting connected to the server at the MuleSoft, and MuleSoft then basically orchestrating between the MongoDB and the Mailjet server. So yeah, that is it. Uh, Let me know if you have any questions in the comment below. Thank you.